Hello everyone, in this lecture we will be going over 2001 AIME 1 problem number 5. Here's a view of this problem. An equilateral triangle is inscribed in the ellipse whose equation is given as such. One vertex of this triangle is located on point 0, 1 and the altitude that comes out from that vertex is contained in the y-axis, so it's perpendicular, it's vertical I should say. The length of each side is what we would like to find out. So I will go ahead and first draw the ellipse like this, and so I have my ellipse, and now I can just mark my x and y axes like this. This is my x-axis here, the y-axis. I know the ellipse equation tells me that the ellipse will go through the points 2 and -2 on the x-axis, and on the y-axis it will hit 1 and -1, so you can easily confirm these points are actually located on that ellipse. Now the triangle will have one of its vertices on this point, and the altitude will be vertical on the y-axis. This suggests that the base will be horizontal in such a way that we have, so this is probably how my equilateral triangle will actually look like. So now that I know how this picture looks like, let's make a couple of observations. So first of all, if we call this point xy, the remaining vertex will have coordinates -xy, which means it is symmetric with respect to the y-axis. And now at this point, let's also make a second observation. As I suggested, the base is parallel to the horizontal axis as well. So now as a strategy, what I would do is, obviously because I need to find the side length, I will probably use the distance formula, but for that, between this point here and this point, but for that I need to find the coordinates of this point xy. The best way to do that would be, probably because we are on the coordinate plane, the best way would be to find the equation of the straight line here and then solve it simultaneously with the equation of the ellipse, which is already given up here. So for that, I need to first find out the slope of this line. Obviously, we have some equal angles here. These two angles are definitely equal. And second of all, we know that this angle will become supplementary to that yellow angle. So therefore, because it's an equilateral triangle, this is 60 degrees, this is 60 degrees, this one is 120 degrees. Therefore, the slope of the line, through 0, 1 xy is, well, it is tangent 120, which is simply minus tangent 60. Therefore, it is minus √3. Therefore, the equation of the line, is y equals minus √3x plus 1, because it is shifted up by 1 from the origin. Now that I know the equation of the straight line, I can go ahead and solve it simultaneously with the equation of the ellipse. All I will do, I will substitute this value for y on the ellipse. So therefore, I have that x squared plus 4y squared equals 4 is implies, so after solving it simultaneously, plugging in here, x squared plus 4 times minus √3x plus 1 is equal to 4. Oh, there's a square here, obviously. I will go ahead and square both sides, so therefore this is equivalent to saying that x squared plus 4 times 3x squared minus, I guess, 2√3x plus 1, and that whole thing is equal to 4. So therefore, what I can do, I can organize, so I will have 12x squared here, and then there's another one, so we have 13x squared, and then minus 8√3x, and finally we have 4, and then there's another 4 here, so they would cancel out. So that's the final equation I have. Let's go ahead and factorize this. So let me continue on this side here. So therefore, that can be equivalently written as x times 13x minus 8√3, which is equal. From here, I can find two roots. The first root is 0, and the second root is, well, obviously 8√3 over 13. Obviously, this root is associated with this point here, and what I have is the second is this one. So therefore, the y coordinate as a result can also be found very easily. But I do actually have a better idea. Instead of finding the y's by substituting into the equation again, and so finding the y for this point and then applying the distance formula for between this point and this point, instead there's a trick. Obviously, I can use the symmetry, the equilateral triangle, that's the side length of the triangle. All I need to do now is 2 times this distance will give me the side length. So therefore, the side length will be side length will simply be 2 times this number here, which is 16 root 3 over 13. So therefore, that whole thing, so if I move that 16 inside the square root, so 16 squared is 256 times 3 would give you 768, I believe. And divided by 13 will also move into the square root, so it will become 169 and the whole thing square root. So when you add these two numbers, we get 937, and that solves our problem. We are done.